let me go over the graph of square root of 4 minus x squared. Now, if you were to plug this or type it into your y equals graphing part of your calculator, you would get some kind of shape like this. And later on down the road, you should be able to tell me just by looking at the equation that that is basically just half of a circle. As you can see, remember, domain is with respect to the x-axis, so I'm really only concerned with what's going on the x-axis. And as you can see, um, it starts here, and you're going to continue down the x-axis, and you're going to stop right there. So really, your domain is really going from -2 all the way to +2. So your graphical representation does support your actual mathematical computation, in which the domain is from -2 to +2. Now let me go over again some common notations. Remember that I said inclusive. Basically, in algebra 1, you had less than or equal to, or in other words, greater than or equal to, which represented either solid lines or shaded circles, if I'm not mistaken. In upper level mathematics, we tend to use more of brackets. So as you saw, our domain was from bracket -2 all the way to +2, and then we closed it with the bracket. Brackets mean that we are including that -2 in our calculation, and we're also including that +2 in our stipulation. Then you have the non-inclusive ones. Non-inclusive is in relation to less than or greater than inequalities, which in Algebra 1 refer to dotted lines or open circles, if you remember that. Well, in upper level mathematics, we tend to use parentheses. So for example, in my domain, for the previous one that we just had was parentheses -2 all the way to +2, and I had a parentheses. That means that I'm taking every value in between -2 and +2, but I'm not including -2 and +2. Those are just the boundaries. I'm not including them, but I am including everything that's in between. So that's inclusive and non-inclusive. So you need to make sure that you kind of start getting adjusted and familiarizing yourself with those kind of notations, because later on down the road, I will tend to kind of include them, as well as for those that will have me next year for calculus. You will see more of it during your summer packet. For those that decide to take calculus with me, you will have your summer packet to work on. Okay, let's go on to actually let me go ahead and do the next one. I'm going to let you go ahead and copy down the question. Now, the example is you have a function which is a polynomial. If you notice, you kind of have to start familiarizing yourself. This is a polynomial right here because it's basically exponents. Your variables are raised to an exponents, and you have a constant. And you're going to be asked to find A, B, C, and D. So go ahead and write those down, but make sure that you leave some space in between so that you can work out the problem. So I'm going to give you a couple of seconds to write that down. And if you notice, you've done this before. You just probably haven't done it to the extent that we are about to do it. So remember that at least you'll be able to do the A part. And in a minute, we're going to go ahead and do the B, C, and the D part as well. So make sure that you write those down. Okay, so let's look at the example. It says that g of x is equal to -x squared plus 4x plus 1. So I'm going to go ahead and x out of this and go ahead and do it in Word. All right, so let me go ahead and make this a little bit smaller, 46. All right. The first one basically is saying that you need to find g of 2. So let's go ahead and find g of 2. Okay, so g of 2. That means that basically you need to, wherever you see an x, you need to basically plug in a 2 in that value. So what I'm going to do is I'm going to go ahead and set this up. So I have some kind of value in there, and I also see an x here. So instead of placing numbers going ahead and direct substituting, I'm going to go ahead and place some parentheses in there. Okay, so as you can see, I have, let me make this a little bit bigger for you. Okay, so I've increased this to basically make it look like your function. Okay, now I can go ahead and substitute. So that's exactly what I'm going to do. And remember, this g of 2 is basically saying wherever you see an x, in other words, now at this point, wherever you see a space or your set of parentheses, you need to plug in a positive 2. Okay, so ignore that negative part that I said. You need to plug in a positive 2. Okay, so I see a set of parentheses right there. I'm going to go ahead and place my 2 there, and I also see another set of parentheses right here, so I'm going to go ahead and place my 2 there. Alright, I did too much. Okay, there we go. Okay, so now the next thing is to evaluate. So let's go ahead and evaluate. Alright, so I have, let's see, 2 squared is what? It's positive 4, but remember that now I have to multiply it by this negative. So if I have a 2 squared here, which is a positive 4, times a negative, that's going to give me a negative 4, okay, plus 4 times 2, which becomes an 8, plus 1. So then once you have it down to something simple like that, you have negative 4 plus 8, which is a positive 4. Then you add 1 to it and you get a positive 5. So for this one, g of 2 is equal to positive 5. Very simple. And this was the A part. Very simple. Okay? So now we're going to go ahead and look at the B part. Now the B part is very different because it's not actually a number anymore. It's actually a letter. So now what's going to happen, okay, I'm gonna erase this right quick. So now again, I'm gonna use the same function, so I'm gonna go ahead and keep this the same. I'll leave a space wherever I see an x, because eventually now wherever I see an x for the B part, it's telling me to plug in a letter T. So this time I'm not plugging in a number, I'm plugging in a letter. So let's go ahead and do that. So if I do that, okay, so I place a T here, I see another space here, so I'm going to place it there. And then all I have to do is basically your last step, which is to clean it up. So if I do that, remember, T, which in this case is positive, raised to the second power is T squared. So a positive T squared, which we have here, times a negative is really a negative T squared. And then a 4 times t is basically just a 4t, and then plus 1. So our answer for g of t is equal to negative t squared plus 4t plus 1. Okay, so that's the answer for the B part. Okay, let's look at the C part. The C part is a little bit more tricky because now it's a more advanced technique. So let's go ahead and do that. All right. So now I have x plus t. I'm sorry, x plus 2. And again, I'm going to set it up as my parentheses. I'm going to use the same function. So here, what's really happening is that now I have to plug in an x plus 2 wherever I see a space. So that's exactly what I'm going to do. And I'm going to minimize it or make it smaller so it can fit into one line. Let's see if 32 works. No. Let's see if 30 works. No. So 28. Nope. 26. All right. So there we go. And I might zoom into it. There we go. All right. So it says g of x plus 2 is equal to, and when I've replaced everything, I get this part right here. Alright, so basically I'm going to do this the long way the first time, and I think after that I'm going to go ahead and do the shortcut method. So this right here is basically the same thing, and let's go ahead and rewrite this. It is the same thing as saying negative x plus 2, let's see, x plus 2 times x plus 2. That's the same thing as saying squared, right? All right, so x plus 2 plus 4 times x plus 2 plus 1. That's perfect. Okay, let me make it into one line, see if I can, there we go. And let me fix that. All right, so here we go. I think what I want to do is I want to go ahead and distribute this 4 to both of these terms in here. So that's exactly what I'm going to do. And I get the following. I get 4x plus 8. Okay, does everyone agree with me so far? All right. Okay, so now let's go ahead and I'm going to FOIL these two terms first. After I FOILed those two, then I'm going to go back and take care of my negative sign. So let's do that. And again, FOILing is a concept from Algebra 1. So let's go ahead and take care of it. So this really becomes, let's see, x squared. First times first, so x squared. First times the second one here, so that's 2x. These two inner ones, so a positive 2 times an x is a positive 2x. And the two outer ones, so a positive 2 times a positive 2, which is a positive 4. Okay, after that, I'm going to go ahead and combine like terms in the inside of that parentheses because these two right here add up to be 4x. And then keep in mind, I am distributing this negative to the three terms inside the parentheses. So in other words, I get the following. I get negative x squared minus 4x minus 4. Then plus the rest of the stuff. So now the last thing is to clean it up and combine like terms. So I have negative x squared. Let's see. What happens to my 4x's? It seems like they go away. So I can go ahead and cancel those out. And negative 4 plus 8 is a positive 4 plus 1, which gives me a positive 5. So all of this now transforms into a positive 5. So I get g of x plus 2 is equal to negative x squared plus 5. Okay, so that's what we get for this one. I'm not going to do example D because I think that I should actually be there in person to do it with you since it's a little bit more. So I'm going to do that one with you. Just remind me to do it with you tomorrow. And I'm going to go ahead and move on to the next example. If the video cuts off, then that's as much as what we're going further into. If not, hopefully I can squeeze it in here. But if it cuts off, don't worry. We'll finish the lesson tomorrow. All right, so let's see. The next example is this kind of function. It's f of x is equal to x squared plus 1, where x is less than 0 and x minus 1 where x is greater than or equal to 0. This one doesn't really require math. First of all, these type of functions right here are called piecewise functions. And that's because it breaks your graph into pieces. So you need to make sure that you know what this is called, first of all, piecewise function, and what happens. It breaks it up into pieces. You will see a lot more of these sooner, especially when you get to calculus. So the question here is evaluate at -1, at 0, and at 1. I really don't think I should show any work for this, so we're just kind of going to discuss this. The first one is -1. So basically what you do is you ask yourself, where is -1? Is -1 less than 0, or is it greater than or equal to 0? I think that -1 is less than 0. So that means you're going to go to this function because -1 falls under this stipulation. So you're going to go in here and you're going to plug it in. So you have -1 squared. Mr. Brown, what happens when you square a negative? It's always positive. So basically when you have -1 squared, that becomes a positive 1. You add 1 to it, and what's 1 plus 1? 2. Right. Okay, the next one is 0. Well, out of these two stipulations right here, is 0 less